Greetings and salutations, and welcome to the last in our series of videos called Linux Bash Shell Script Basics. This is part 3, and in this video we're going to talk about nifty ways that you can put text on your screen. We'll also look at having your scripts create log files so you can keep up with what they're doing, especially if they're running in an automated environment. We'll look at creating loops to make them do things again and again, and then we will get into menus and using the read command so that you can create truly interactive scripts that act like programs and not necessarily just like simple commands that you type into the terminal, they do their thing, and then return you to a prompt. Before we get into that, though, in the last video we demonstrated up. Well, we talked about up, we looked at how it worked, but I never actually ran the program, and somebody pointed that out to me and said, you know, you didn't actually show how it worked, and I was a little disappointed. So we're going to go ahead and run the up script, and we're doing it on another machine on the network because I just updated this computer, so this way we'll actually have something to see. So as you will recall, the end of the last video we went through all of the different functions of up, and the first function that we talked about was just update. So if you just type in up, it goes through all of the tests, and since it doesn't match any of them, it runs the function called update and then the function called exit. So we'll go ahead and run that, and the first command is sudo apt update. So it is asking for my password, and it's updating the machine, and this is my Linux Mint machine here on the network, and it's saying that there's a couple of things that can be upgraded. We got a few small packages. This won't take too long for it to upgrade, and this is what it looks like, and when it's done it tells us the update is complete and we're good. So that's the first way to run it. And then we have some options that we can use with up. We talked about that. And remember, these are the tests that are in the execution part of the script that call up these different functions. So if I would put in the help function, let's do that one first. It displays the help page. Now this is a very simple help page. It doesn't actually go into a pager like less or anything like that. If you've seen videos where I have shown more sophisticated help pages, they go into pagers, but this one just displays on the screen and dumps you back at a prompt, so that works fine. And we're going to show you exactly how that is displayed on the screen here in just a couple of moments. So the last thing that we want to look at is the clean option, and this just runs a different set of functions that we talked about. So this will run the update function, which is sudo apt update and sudo apt dist upgrade, and it's going to do that. We already did it, so it's not going to find anything. And then it's going to run sudo apt auto remove, which will remove any extra packages on the system that are installed that we don't need, and then sudo apt auto clean, which cleans the apt cache. And we talked about how that works. And now you can see the output there that it has deleted these packages that were in the cache toward the end that we can't actually install again, so we have no need to keep them around on the system. So that is what up looks like when it is running. So let's go ahead and, well actually I need to power this machine off. So I'm not going to be using it anymore today. My kids can power it up when they get home. We need to get on and start talking about using commands to display things on the screen from a script. Now thus far we have touched on echoing commands, and we've talked a very little bit about here documents because we've run across them in demonstrations. There's a lot in between there, so let's talk about that. The echo command is the most basic, and we have the first part of Lincoln's Gettysburg Address here that we're looking at, and you'll notice that if you run the echo command without any text after it, what it's going to do is it's going to create an empty line on the screen. So it's kind of like creating a return so that you have spaces and empty lines. So that is how this first block of text is put up there. Everything that we want echo to print on the screen has got to be in quotations. We've got to keep up with those quotations and make sure that the lines don't get too long and all that kind of stuff. And you see, as we get more text, it gets more cumbersome and a little bit more difficult to deal with. So what you can do is use one echo command and put a block of text in there with one set of quotations on one side and one set on the others. Now, technically speaking, it will kind of ignore if you add quotes in there. But what can happen is that if you have anything in here that the shell thinks is a command, it might get tripped up. So what you have to do in that situation is to escape that within the text. And you can run into situations where things just don't render right for one reason or the other. So using these methods are fine for 2 or 3 lines or even a little block of ASCII art. It's no problem. But if you're getting beyond that, we need to get into another way of doing this. But before we move on from echo, I do want to mention that it is possible to use escape codes. Now, in the last video, or in this series a while back, I think in video 1, I was talking about accepting something that is in a script or in a text so that the shell doesn't see it. Well, that is more commonly known as escaping that. I learned it as accepting a long while back, and so we're going to call them escape codes here, but it's the same thing I showed you about being able to add the little backslash and then the terminal says, oh, well, I don't need to use that, or the shell running in the terminal. But you can use escape codes to do really groovy things like add color. You can display text in different colors, and this is going to depend on whether the terminal that it's running in is capable of doing that. So, for instance, you have to have a program called tput running to render color in one way, or you can use ANSI colors, which is another way of doing it. Now, if you want to know more about doing that, you can just do a search online, show colored text in bash script. That's all you got to do. And all kinds of crazy stuff will come up. And there's all kinds of different ways to do it. I prefer to stay away from color simply because of the fact that it doesn't incur extra code. And then there's always the uncertainty about how it's going to run depending on what terminal you're running it in. But I do like this little escape code right here. And I use it quite often. And this little guy, what it does is it puts a new line above the line that you want to echo. So it makes it a little bit more compact. If you want to echo 3 or 4 lines and you're using 3 or 4 echo commands, but you want to make them all have a line between them, you can just put this little escape code right here in front of it, and then it will add that new line. So that's one that I like to use. But when you're dealing with tightly formatted text that you want to display a certain way on the screen, then you're going to move into something called a here document. And this would be for things like help pages, anything that's a long message that you want to give your users on your script, anything like that. This is how you would do it. And a here document is really cool. The way it works is that you have to use some sort of display utility like cat, that's very common, or you can even pipe it into a pager like more or less, and I'm pretty sure that you could even throw it into a line editor, like Nano or VI or Vi, whichever one you want to call that thing. You can kind of throw it in there if you want to using this same command. Now, whether you'd want to do that or not, but you might have some text that you would like to have the user to edit and save somewhere. I don't know. There's crazy reasons for doing that. I usually use cat or less. And so in this case, we have an example of how this works. And the basic format is that you have this command right here that starts a here document. And what this basically says is that everything after this command, this line right here, is going to be funneled into cat, and cat is going to display that on the screen. And what it's going to do is it's going to look for this end token right here called EOF. And EOF is just what I've chosen. It's pretty standard. You can designate anything as a token if you want it to. EOF with an underscore on either side, it means end of file. That's the way I learned it in the book that I read it in, okay? So we come down here and we have more of the Gettysburg Address, and it's kind of gornied up on this screen because we have this kind of blown up. It's not a full 80 characters across to show in the video here. So it will read from there to there. Now, there is no limit to the amount of text that you can have in a here document. And you can have any characters you want in a here document. There are no characters in there that are going to mess up your terminal or your shell there by being thought as being commands. So we could have backslashes in here if we wanted to, and it would actually print on the screen, because everything within that here document from the beginning of the command all the way down to EOF is just text that it just spits out on the screen. It's just like it's reading a file, but we're actually putting it in our script. So what I have done to demonstrate all of these is I have created a script, and I put it in the junk directory that we've been working in. And let's take a look at that. We will nano... what did I call the thing? That's a good question. I've forgotten. I called that script, display. Gee, that's really obvious. Very creative on my part, don't you think? Let's look at that in Nano real quick, just to see how the code looks. And I put some comments in here. Let's get this one. Maybe we can blow this up one bigger. Can we get away with that without it rendering funny? I think we can. All right, so you see that Nano sees everything in Echo and changes the color of the text. That helps you keep up with whether you have your quotes in the right place or not. So right here we have an extra space at the end. Let's see. Let's go down here. I don't think I showed this before, but I'm going to kind of drive this point home about colors in your editor. See how that went away? So now it tells me that that's quoted text. So this is the first way that we've already shown. And we have the next way, which is to use one quote. And it's not changing the color in there because it's just a big block of text. It doesn't really know that it's within an echo command. At least the editor doesn't. And then here I've shown where it will add the extra line. And then here is our here document properly formatted because the text size on this screen. And so this is what it's going to look like. So let's go ahead and we will exit out of this. No, I'm not going to save changes. And we're actually just going to run this thing. So we'll run display.sh and you'll see what it looks like. So now we have printed the text on the screen. And so this script shows how text is displayed on the screen is where it begins. And so the first, these two look exactly the same right here, even though we're doing different ways of doing that. But then we get down to our here document, as long as we're on an 80-column screen, look how nicely that is up there with our quotes in it. And we have the indentations proper. And this part up here, President Lincoln's Gettysburg Address, that is centered. So that's one of the big advantages to using here documents, because it's a what you see is what you get type situation. It's even separated from the left here with a margin of one space. That's the way I like to do it when I do help documents. It makes it a little bit easier to read, and it kind of keeps it away from prompts and stuff like that. Just that little bit of indenting. So there you go. That's how that works. All right, so let's move on from there. That is input and output. Now, what we're going to do is in this part of the video, talking about sending script output and error messages to a log file. This is going to have to be kind of a stretch in your imagination of how you would actually make this work. What I have done is I have chosen some commands that I used in XBT. It creates a log file which it puts on the external drive that it uses to store the backups. This is a kind of a complicated way of doing it. Log files can actually be really simple. I mean, they don't have to be, especially if you're just doing it for yourself. You may just want to catch all the errors from a command that runs in your script, or you want to, if there is an error, you want it put into the log file so you know. If you're creating a script that's being run automatically in the background, let's say by Anacron or a cron job, then log files are really useful, because in those situations you have no output going anywhere from the script. You have no idea what it's doing, and you could put that in your own home directory, and you could call it .myscript.log, and you can read that at any time. But in XBT, it's a program that was written in Bash that is designed to be run by users everywhere. So we have a little bit more sophisticated log. So what we're going to do is just kind of go through the commands here so that you understand what the deal is. So when you first fire off the XBT program, and once it realizes that there's this drive is connected and ready to go, it will actually go look and see if the log file exists, and that's what this if statement right here does. So the first line of the if statement actually tests for the file itself. You notice it's a very long path to get to it because it's media, the username, XBT drive, XBT backups, and then the name of the file is the log file is xbt-backup.log. So if that does not exist, and we're testing if it doesn't exist, you can see right there we have the exclamation point in front of the file test parameter there in the test command. Then what it's going to do is echo XBT, external backup tool, log file, and it's going to put that into a file. We're redirecting the output into a file that's going to be in that same directory called XBT backup log. That just generates the file and puts one line in it, a generic title, so that that log file exists. Now, as the program runs, we need to create a new log file for each time it runs. And then what we're going to do is append that to that file we just created. So we need to create a new temporary file in the /temp directory. Now, as a user running in a terminal, you always have access to temp. You can create files there, directories, move things around, whatever, and so can your scripts. So in this case, what we're doing is we are creating a variable, just a real quick variable right here, not declared at the beginning of the script because somebody might start it and walk away and whatever. We need this to be very timely, called date and time, and we are throwing that into where we're getting that from is the output of the date command itself. So date and time equals date, taken at that moment. That grabs the current date and time and puts it in a variable. And then we use the echo command once again to, first of all, create a new line. There's that little exception code right there. And then it says the backup is sent to the XBT USB drive from the machine. That's the host name and the user right there. Now, really astute viewers will notice that these are lowercase. And when we talked about shell variables before, they were uppercase. That is because with the XBT program, that is one of those instances where I have captured the shell variables and created local variables in the program itself. So that's how that works. Anyway, it will echo this line, and it's going to put it into this log here called temp, and then it's going to echo the date and time, any errors. So that this will actually have two dates and time here. One of them is going to be when it starts, okay, and then there's going to be one at the end. So there you go right there. So once we have created those lines in there, we're going to use redirection to send only some error messages to a temporary log file. This is useful when you have output on the screen from a command. You can grab the error messages from it, or if there's no output on the screen from a command or it's running in the background. You can grab those error messages and then you can put them in that temporary file. And then what I usually do, what I've done in XBT, is then I will alert the user at the end, hey, there were some errors, check the log file to see what they were. Because error messages can be quite verbose. They can scroll up the screen and take up a lot of space. And in the case of a program like XBT where it's backing things up, what's going to happen is that those error messages are just going to scroll by anyway. So we just catch them and put them in a log file. And then we're going to talk about using the T command to append screen output to the temporary log file. Now this is the case where we are echoing something to the screen and we want to have it appear in the log entry itself. So therefore we have echo XBT backup successfully completed, and then we grab that time once again. And each time that this comes up, is if there's time that's gone by, we refresh that variable, by the way. That little time and date thing happens over and over again. And so it catches the time at the current time. You may think, since you only saw it up there once, that it's only happening once. It's actually being done as the process is going. It's kind of creating a timestamp as it rolls through. So we take that, and then we throw that in there, and now we're going to send this into the log that we have running in the temp directory. And we'll also display it on the screen. That's what T does. Now, the A option on T means that we are appending to that file, which means we're not deleting all the stuff in the file and creating a new file. No, we're just looking for the end of the last line in the file and then putting that on there. So after all of that is done, we have a temporary log file that we need to append to the permanent log file because we're not looking in temp for log files. So that's what this command right here does. So what it does is that we use cat to read all of the contents of the temporary file that we've created, and then we will stream that directly into the log file. Something we haven't seen thus far in the redirects here, if we have two of these arrows that point that way, that means that we're going to append to the file. We're not going to blow it out and start over. We're going to add whatever text that we're reading from the temporary file that we created in the temporary directory into our permanent log, and it goes in there like that. And then finally, when it's all done, the entry looks like this that ends up in the XBT log. I'll show you the log a little bit later on because we are going to use XBT as an example. That's really the only program that I have written in Bash that is purely interactive and runs with menus and things like that. So we're going to be moving into that at the end of this video. Your particular log files don't have to be this complicated, as I said earlier. They can be very simple things. You can just have it append to a file. You can have it create a new log file every time it runs. Whatever you want to do, you just have to poke around, and the logic of that will make itself clear depending on what your program is doing, your script, and what information you need to gather from it to know what it was doing when it was running before. Hopefully that makes sense. Let's move on to something that's a little bit easier. This we're going to talk about using loops. Now there's all kinds of loops. There's while loops, there's until loops that do different things and work with different parameters. But one of the biggest loops that is the biggest help to people writing terminals, writing scripts to run in Bash in a terminal, is called a for loop. So we're going to mainly be talking about that. And a for loop basically takes a list of files or a list of arguments, and then it does an action on it, and then when it's done, and we move on to the rest of the script. So the first one I'm going to show you is a for loop that I have created for my install script. I have a install script that I use for Ubuntu 18.04. So if for some reason or another I want to move things around on a hard drive, or I have a crash on the system or something like that and I need to rebuild it, I have this script that I just install Ubuntu, boot it up, fire this script off, and it goes and it grabs all the software I need and it updates the system and all that kind of stuff. And one of the things that I have is a whole bunch of deb packages that I keep in a directory, in my downloads directory. I call them packages. And these are things that aren't necessarily in the repositories that I'm installing from deb files. And also the XBT program, I have that in a deb file. So when I install it on my own system, that's how I'm doing it. If you would go grab XBT off of GitHub, you just take the deb package and put it somewhere and click on it, and it would install on your Ubuntu or Debian system as well. And please do that if you'd like. But anyway, what this code does is it looks to see if I have gotten to a place where I have synced up the home directory with my backup. If I've already done that, then I'm going to have this directory on there. So it looks to see, and so this if statement runs this way. It says, if this directory exists, which is home, it's my username, downloads package. I could have put Joe in there if I wanted to, but I've gotten in a habit of using that shell variable. And then it comes over here and looks for that directory. If it finds it, it says, good, I'm going to install local deb packages. And then the first thing it's going to do is change the directory and jump over to the downloads/packages directory using pushd. Now, pushd is a way of changing directories where it doesn't matter what directory you're coming from. It doesn't make any difference because it takes the current directory and it pushes it on the memory stack, and then we jump over to a directory, we do something for a while, and then when we do popd, we pop right back to wherever we were. It does not matter where you're running this in the file system. It will always do its work in the directory we go to and then go back to where it came from. Just using a cd command like that doesn't necessarily do that the way we want it to. So that's why we're using that. So once it gets over there, we use the for command to create a variable called file right there. And then it grabs the stuff from the directory. It actually just looks to see what's in there, and I'm telling it in the current directory, which we should be in packages because we just, pushd over there, look for anything, star.deb here. So that's all deb packages. And then it's going to feed that with the do command over here into our program gdebi. So it's do sudo gdebi in, and then this is our variable that we've created. So this is the stuff that's in there, and it will do this one package at a time. When it does that, it will loop back up, and then it will grab another one here in the for command, and it'll just keep going in a constant loop until it runs out of package names. So let's say that I have 8 packages in there. It's going to just go 1, 2, 3, 4, 5, 6, 7, 8. When it's done, then it'll be done, and it won't have any more packages to work with, so it will let go. So it's taking... we're creating a variable called file, throwing in the first deb package as it finds, running it, going back up to the loop, and it's doing it again. Once it's done, it's done. After that, we pop D, which puts us back in our correct directory. And now, if we have a situation where this directory is not already on the system, then I have an else here that just stops the script just for a second. And it says that we don't have local deb packages. There's no the directory doesn't exist. Local deb packages can't be automatically installed. And it uses the sleep command here for 5 seconds to stop the script long enough for me to see it when it's running. Because I usually kind of keep an eye on it even while all this automation is happening. So I just did that for myself. Now what I could do if I wanted to run this completely unattended is I could throw that in a log file, but I don't need to do that for this script. But there's a case right there for needing a log file. It's like, oh, it didn't do that, so you need to have some way to alert the user, hey, it didn't do that, or whatever. You get the idea. Here's another simple loop that grabs file names from the command line arguments and runs a function called display. This is actually the program that I'm using to display this text. It's called show. And really the way it works is that I have a display function which does groovy things like removes the cursors from the screen and automatically formats the text to fit in whatever size terminal it's running in and that sort of thing. So that's what this is right here. And this is really super simple because what it does, and once again it's a for loop, is we create that thing called file, and that's where we're storing it, and then we're grabbing that from the arguments 1, 2, 3, 4, 5, 6. Remember the @ sign, as I mentioned when we discussed arguments, is shorthand for all of the arguments. So it just runs through the arguments and it does this, it displays them, and when it's done it comes back. Now in this case we didn't have to put file after here because it's actually implied In the case of this one, it was necessary because we're running sudo gdeb, a program in there. So we want to make sure that that is quoted properly when we're running that program. But here we don't actually need to do that because it is implied that we will run display and file whatever's in that particular variable that we've created is going to automatically be the argument. So that is how that works. Now, if you find yourself needing to do this, this is another case where you can go search for exactly what syntax is going to work best for what you're doing. And you're probably going to have to test these things to make sure they work. But there are all kinds of different ways of laying these loops out. And like I said, we've just looked at 4 loops. There are other ones as well. There's while, until, whatever situation you happen to be needing a loop for. Now what we're going to get into is how to make our scripts interactive, because when you're running a program, sometimes you may want to stop and ask the user for some input of some sort. The simplest one, of course, is with, just, do you really want to do this? So I have grabbed that also from the XBT program. And so what we do is first we echo the question that we want to ask. In this case, are you sure you want to restore now, which is for the restore function. And then we give them choices here, and their choices are yes or no, Y or N. Now, the read command grabs that, and it throws it into a variable called choice right here. So it reads whatever you type next. It stops the program from running, and it waits for the input, and then it throws it in there. And you will have to, you know what, I honestly do not know off the top of my head what these particular arguments to the read command do, what those options are for. So you'd have to go look that up, but I'm giving you a general idea of how it works, okay? When I originally did this, I went and found those arguments and figured out what they were, but now they escape me, and now if I need to do this, I just copy and paste it. But anyway, so we grab whatever they type in. If they put a little y in there, then we're going to assume that they want to do yes. Anything else that you would hit on the keyboard would go in there, and it wouldn't be a y. So that would automatically mean that you didn't want to do it. So what we've actually done is we've made the no answer the default answer. So if you just hit enter, you'll see that a lot of times when you're installing things in a terminal. It'll stop and prompt you, and then it'll say the default the answer is Y. That means you could click anything and it would be okay. So what we're going to do here is use an if statement to test for that. We're just seeing what's in choice, and if it equals Y, then we're going to run commands to complete whatever action it is. It may be just as simple as if you say yes, then we're going to call up a function, the function will run, and then the script will continue, and if you say no, then we're not going to run that function, and we'll exit the script or we'll go do something else. So that's what else does. If there's an else there, then that would mean that you want to do something else, like exit the script or have an alternate plan. The else, of course, is optional. You could have it where if the person says no, it just doesn't do it and continues on to the next line anyway. I mean, it could be that you're asking them if they want to do something optional that you're pulling in, not just necessarily the next thing logically in your script. So hopefully that makes sense, but you begin to get the idea of this is all top down, and you're trying to figure out what's going on here. You can also use the read command to pause without asking for specific input. And if you go asking how to do this, you're going to get some people in the community who will bristle at you and go, why do you want to do that? You shouldn't do that. Because there are those who feel that bash scripts should be automated to the point where they run and then dump you out at a prompt. And if you put something like this in there, what happens is that you can't automate the script anymore. But this is how you do it. Let's say that you have a page full of text, a big warning that you're putting up on the screen or explaining what's going on. Let's say that you're writing a simple terminal game, right? And you need to have information that you feed to people before they move on. This is how you would do it right there. And that would mean it's not looking for any input. It's not putting any variables into the system. It's just whatever key you press, it just moves on. That's all it does. That's what right there. That's what that means. And the next little use for the read command, which is pretty cool, is that you can use it to grab whatever text somebody types in and discard it, which is something that you might have to do if you have a process in your script that runs for a very long time. Like, for instance, in the XBT script, I ran across the need to do that because when I was doing the testing, I was running it one day and my cat walked across the keyboard. And so I called that the Percy patch. When he did that, I realized, because then all this gobbledygook appeared on the screen, it messed up my program and it didn't run quite right. And I went, wait a minute, hold on. So what I ended up doing was going out and figuring out how to grab random input from the keyboard and not having it show on the screen or sit in the buffer. Because what will happen is with a long process is that whatever you type on the keyboard will be in the buffer, and as soon as it's over, it will be sent to the shell as a command, just like it's a command. So it's like just putting gobbledygook on the screen between these two commands, and the script goes, I don't know what that is. Sometimes it doesn't hurt anything. Sometimes it just messes things up, or you get some random error message. It's weird. So that's what that's for. Now, there is a lot more to the read command. There is a lot more to how it works, and there's a lot. I mean, you can have it where you can have many choices for people. You can set ranges. You can set the read command to look for invalid input, and it'll say that's not right, that sort of thing. We're not getting deeply into that because if you are going to be doing that, then what we need to talk about is menus. And I'm going to show you one menu that I use in the XBT program, and that is called a case menu, or a case statement menu is what we're talking about. And the read command with a whole bunch of if statements, usually put in what's known as a nested if. That's where it's if this, if this, if this, and then you get this. A nested if is pretty wild looking code if you ever see it. You see those a lot in configuration files because it's if this, then do this, and then if that, do that, and it just kind of goes on through. Well, they're complicated to write. So let's say that we have XBT here and we have a menu that looks like this. So what I'm going to do is I am going to actually plug in the XBT external drive that I use to my computer. You'll see, I don't know if you'll see that pop up, but it will. So we can actually run the program. But first let's talk a little bit about what this menu does. So I have a list of choices for the user to choose from, and you can press the number of your choice, and when you do a case menu, you don't have to press enter. Whatever you press, it's just waiting on you, and as soon as it gets the input, it executes the command. So that's what that looks like. Now, there are some other codes. There's some other code in the greeting function in XBT that's between here and there, but I have excised that for example here, and we're just going to look directly at the case menu itself. So we see the familiar read command there that we have before, and it looks for whatever the user types in. Now, for whatever reason, that is showing a little bit strange on the screen because this is supposed to be lined up with that, and I'm not quite sure what's going on with that. So I hope that doesn't make it harder to understand. But, so we go ahead and use the read command to grab whatever they type, and then we have the case statement starting right there, and then we have the choice in. Once again, we're doing a loop. You can see that we're doing this, so it's whatever they type in, we're going to feed it to these parameters. So if they type in a 1, that matches up with this one, which will run the function called backup. And if they put a 2 in, it'll run restore. If they put 3, it'll set up the drive. 4 will open up the help page. 5 will view the log. And then for 6, we have a few little simple commands. 6 is refreshing USB status, and what it actually does is it just resets the screen without an error message. That's all it does. It waits a couple of seconds, and that's if you plug in a drive and you want to make sure it's there, okay? So what it does is you press number 6 and it runs the command clear, and then it echoes with refreshing the USB status, and then the system sleeps for 2 seconds. It clears the screen again, and it runs the greeting, which is this menu. So it always goes back to the greeting. And we keep going here. I mean, if we go to 6, then, or rather, the 0, that's how you exit it. So it is clear, echo, and then it says exiting XBT, and then it sleeps for 2 seconds, and then it puts the cursor back on the screen, because when XBT runs, that's what this part here does right there. It actually removes the cursor, and then we just exit the program. And then this right here, this last entry in the case statement, basically says if they put anything else besides 1, 2, 3, 4, 5, 6, and 0 in there, we're going to consider that to be an invalid input. So whatever they put in choice, if you put in the letter R, it would go, that's not any of this stuff that didn't catch and it didn't run all the way down. So what I'm going to do in that case is I'm going to put on the screen, not a valid choice. Please try again. Once again, it's going to sleep for 2 seconds, which means you'll see that error message for 2 seconds, and then you'll clear, and it'll go back to the greeting. Now, ladies and gentlemen, you can see here that we have 2 commands that do exactly the same thing. 6 and just typing in garbage will do the same thing. The only difference is what message it prints on the screen. So refreshing USB status, hey, you think it's doing something. It's not really doing something. It's just waiting 2 seconds, reloading the greeting, because there is a piece of code in the greeting there that actually looks to see whether you've plugged a drive in or not. So in order to get that to work, you have to refresh that greeting. Well, you'll get exactly the same result just by typing in gobbledygook, and it'll do the same thing. So there you go. I mean, isn't that pretty cool? I love case menus because they're actually really simple to do. Much better than doing if statements or something like that. So let us actually run the XBT program. And I'm just going to call it up. And there's our menu. So there's certain things I'm not going to do. I'm not going to press 1 for backup or 2 for restore, because those take a very long time to run. But we can do some pretty interesting things here, like we can go to set up the drive, for instance. We go here, and now it asks us if we really want to do it. Well, here's a case of a read command working right here. Now, if you don't type in Y, you can press anything on the screen, enter, or any other key. Watch, it's going to dump me right back out, and it dumps me to the greeting. So, if we go to, let's look at the help page. This is once again a here document, which is being fed into less. That's all that is. Now, the less program is running, which allows us to scroll up and down with our mouse, or we can use the space bar to scroll up and down, and then we get down at the end, it says end to leave less, just like it is when you run it from a command line. Q dumps us back to the greeting. Always come back to the greeting in an interactive program. What can we do here? We can view the log. We talked about creating the log file. So let's hit 5. Well, there's what our log looks like. And once again, we have dumped into less, except we have a special parameter here. We're looking at the end of the log file, not the top. So to look at the top, we'd have to, scroll all the way up to whenever this was started. And there's the line that was created in the log file right there. See that? So to get out of this, just like with any other, less, just get out. And I'll show you here just real quick. So if I hit 6, see it refresh the screen. But if I just hit the letter K, It says, that's not a valid choice. Please try again. But it still refreshed the screen. So anyhow, that is, ladies and gentlemen, all I have to say on scripting. It is said that every man rises to the level of his incompetence, and you have just risen to mine. Now, there are many things that we did not cover in this video. And we didn't talk about things like ranges. We didn't talk about things like using sed to edit text dynamically that is fed in from somewhere else. We did not get into using grep to find information that you want to feed into variables or into a command. We didn't get into any of that stuff. And the reason why is because it's tedious and it's hard to explain. And the absolute truth about that is the fact that it is, you don't understand it till you need it. I mean, at least that's what I have found, is that when you're writing a script and you come across something and you go, hey, I want to do this, this, and this, what that does is it spurs you on to go out and do more research and open up your book or go online and look, and then you see how those tools are used, and you go, oh, okay. So the next time you run into something like that, you can say to yourself, well, I know that I could use sed to format that text the way I need it to. I might not be absolutely sure how to do it, but I can go look that up. So it becomes a matter of not necessarily knowing everything by rote, but it does, after a while, become where you kind of know where to look. One of the things I put in my notes here before we get out of here is that we talked about using scripts with menus and how some people in the community don't particularly like that. I would like to see more people writing programs this way, because Bash is a powerful programming language. It's very stable. It doesn't change over time. So you can write really long programs in Bash, but a lot of books will discourage it. They'll say, oh, if you're writing in Bash, then you're doing this, then probably you would need to use a more sophisticated language. And yes, in some cases that's true. But I kind of really like programs that you can put in the menu that open up a terminal and do things. They're very useful, and they have a very small memory footprint, and they tend to be very stable. They work for a very long time. They don't rely on, the standards of things like whether Qt or GTK is going to match up and that sort of stuff. I will say that when I did XBT, originally when that was released as a fully interactive program, some people complained about that. So what I ended up doing with XBT was I actually had to add some code in the program that would allow you to run it from a command line directly. So if I do XBT and then I put log on it, and with one L, then what happens is that it'll just display the log file and it'll dump you back to a prompt. We can also use help here to show how that works, and it does exactly the same thing. And that's in the documentation that you can do that those commands exist. But originally they did not, because I envisioned it as being a completely menu-driven program. But some people who like to work in a terminal, they said, oh, I would rather be able, just like to grab those, like if I want to back it up or do something, then I can grab it directly. So I added that in there, and it actually detects with testing, simple testing, whether you've fired this off from a command line or how are you doing it? Are you doing it from a menu, or are you doing it directly from there? So it looks for those options, and when it sees that, the program actually goes into a different mode and it exits without dumping you back at the greeting, except if there's an error. I couldn't figure out how to make it. I could have, but what I made it do is that if you run into an error, it dumps you back in a menu and it goes, hey, what do you want to do? So anyway, little aside there about that. But I like these kind of programs, and I'd like to see more of them out there, which is one of the reasons I'm doing this videos. I just had a really strong feeling that somebody somewhere needed this series of videos, so I hope you found it useful. Some other tools and resources that you can look at: you can use Git and websites like GitHub to keep track of your versions, and you can share scripts with the world. Somebody asked me if I'm ever going to do a video on Git. I don't know. I might. It is so boring. Git is like, I don't even when I go use Git, I actually cheat and have a list of commands that I have stored somewhere, because I'd constantly have to go look it up. It's just not the world's most user-friendly interactive program. It does exactly what it needs to do, and it is really quite useful, but you have to remember some commands to make it work. And then, of course, the payoff is being able to put your stuff up on GitHub, share it with people, get input from them, and they'll open up issues and stuff like that. It's very cool. My favorite book about Bash is The Linux Command Line by William Schatz, and you can download that thing for free, and I've got the address here. And also, somebody pointed this out. This is a resource that I use all the time. It's an online A to Z index of the Linux command line. Now, these links will be in the description for the video, but the entire text of this is going to be available on the EzeeLinux website. I'm going to do that the same way. So I'll put these links at the bottom on, the web page. The YouTube video description, and the rest of it will be on the web page. Does that make sense? I certainly hope it does. Okay, gang, this has been a really fun project. Thank you very much for watching all the way to the end. Your feedback is always welcome. You can check out EzeeLinux.com for more about Linux. You can join the discussion at EzeeTalk. It's free, secure, and fun. And please be sure to give EzeeLinux a like on Facebook if you are a Facebook user. And we will talk again soon. Thank you very much.